Morning, students. How are you?
Fine, sir. And you?
I I am good now. I mean, could be better, but giving thanks. Right. Um. right, Um. Where were we the last time? What topic were we on? Hello.
Sir, I wasn't here the last class.
Right. I remember. I remember missing.
Good morning, sir. The last thing we did was differentiation of the exponential function.
Okay. Cool. Right. Differentiation of the exponential function. Okay. Um, Did I look at the square root function with you? I did the square root function, right?
Sir, could you repeat that?
No, I'm asking, did I look at the square root function?
No, sir.
Sir, what function?
The square root function?
No, sir.
All right. Right, let me look at the square root function too. You sure I never did the square root function? Didn't I not look at it in one of the questions that we did?
So it was the exponential function, not the square root function.
Yeah, man, but I'm almost sure one of the past paper questions we looked at.
Was it number 1? Y
It was,
equals 30 to the 7 minus the square root of x to the 6
yeah, man,
plus.
yes, Randy, that's the one. Yeah, man. So I looked at it briefly, but let me see if I can show you wholesomely know what it is that is. It's all about. All right. So let us look at the. Let me formalize it. I know I did one question within it. Let us see if we can get a little bit more information from it. So it says whenever you are presented with the square root function, you'll be the first rewrite the function raised to the half power. Remember, I said to you the last time that the nth root of a is equals to a to the 1 over n. Whatsoever is in the sleeve of the square root sign is going to be reciprocated. Whatsoever is in the sleeve of the square root sign is going to be reciprocated. So this n in the sleeve of the square root sign is really n over 1. And when you reciprocate it, you have 1 over n, which is known as the nth root of a. All right? So if I have y is equals to the square root of x, then y is going to be equal to x raised to the half power. And that's what it is that we're going to differentiate. So what we're doing here now, we're differentiating normally. So this is a half. Let me spotlight it. Hopefully I can get it. So it's going to be a half. This 1/2 is multiplying in front of this x to give me this 1/2. And then I'm going to subtract 1 from the power. So a half minus 1 is going to equal to negative a half. Do you understand that? A half minus 1 is going to be equal to negative a half. Can you see that?
Yes, sir.
Right.
Yes, sir.
So just remember now, whenever you're given the square root function, always convert it to whatsoever it is raised to the half power. Very, very important. And so often they give you questions like this on the exam. Don't worry about it. Just raise it to the 1/2 power. And you should be good. And then you differentiate as usual. All right? So remember again, we don't leave our answer as a negative index. We always try to leave it as a positive index. So what we're going to do right here now is to reciprocate in order to get a positive result. So watch me. This x to the negative a half in the numerator is negative a half. But if I put it in the denominator, it's going to be positive a half. So this is what I'm going to do. I'm going to put it as 1, because this half is the same half. I'm going to put it as 1 over x to the positive a half. And when I multiply 2 by x to the half, I'm going to get 2x to the half. But remember now, x to the half is the same thing as the root of x. So my final answer is going to be 1 over 2 the root of x. Tell me if you're understanding what I just did right there.
Sir, can I go back over that, please?
No problem. So when we look at the square root function, it is always whatsoever is in the sleeve of the square root sign that we're going to reciprocate. So they can give you the square root of x, as in this case. Now the square root of x is the same thing as x raised to the 1/2 power. So this is going to be x and raise it to the 1/2 power. Why 1/2? This 1/2 is representing the square root. The 1/2 is representing the square root. So once I do that simple conversion first, then I'm going to go ahead and differentiate the function normally. When I differentiate the function normally, it's going to be a half. It's going to multiply in front of here to give me this 1/2. X to the half minus 1. Remember, when we are differentiating, we always subtract 1 from the power. We use a power to multiply by the coefficient, and then we subtract 1 from the power. So when we subtract 1 from a half, we're going to be left with negative a half. Please do not make the mistake and say 1 negative a half minus 1 is going to be positive a half. It's going to be negative a half. And then you have to reciprocate it in order to get the positive power. So in reciprocating, remember from pre-calculus, a to the negative m is going to be equals to 1 over a to the positive m. A to the negative m is equals to 1 over a to the positive m. So what I'm doing right here is to convert this x to the negative a half into a positive value by reciprocating it. Now, when I reciprocate it, I'm going to say 1 over x to the positive a half. This 1/2 remains the same. And all I do, I multiply the numerators. 1 times 1 is 1. And 2 times x to the half is 2 times x to the half. But remember now that x to the half is the same thing as the root of x. X to the half is the same thing as the root of x. So this x to the half, I'm going to convert it to the root of x. Tell me if that's a little clearer for you.
Yes, sir.
Right.
Yes, sir.
I I have one projected for you. Y equals the root of 2x plus 3. Try that one for me. Y equals 2x, the root of 2x plus 3. Are you understanding what to do? All right, I'm seeing an answer here, but are we okay? Are you okay? Someone talk to me. We all finished now?
Yes, sir.
All right, good job. So I'm going to, I saw some responses. I saw some responses, and I'm going to just double check to see if you guys are correct. Thanks as usual for your participation in making an attempt. Who got that answer? Nobody got that answer?
Sir, you're a bit off so fast. Oh.
No, because I'm going to do the question now.
Oh.
Anybody got that answer that I have 1 over 2 root of x? Somebody.
Sir, I just put the 1 over 2x plus 3. I didn't put no square root or anything.
Me either, sir.
I honestly forgot to multiply it by the differentiation of everything inside of the bracket. So I skipped
You
that
might-
step.
How
Yeah.
are you? How are you here? All right. Oops, it is. I'm sorry. So let's go. So y is equals to the root of 2x plus 3. We're converting to x plus 3, the root of 2x plus 3, to something that is more workable. So we're going to let y be equals to 2x plus 3 raised to the half power. Now we're going to differentiate. So we're going to get dy by dx is going to be equals to a half times 2x plus 3, and you're going to get the minus 1/2, right? Because we're subtracting 1 from the power times 2. And we call power rule.
Sir, the 2 come from
So,
where so we're supposed to assume say the outside value are 2, right?
no, that this 2 is a differential of the inside.
Oh yeah.
Differential of the parentheses. All right, so I have to differentiate that. I'm gonna differentiate it. What I'm gonna do is to I'm gonna differentiate it. I'm gonna multiply by the I'm gonna multiply by the differential of the inside of the parentheses. Multiply by the differential of the parentheses. You got that?
Yes, sir.
So now what I'm gonna have here is going to be dy by dx. It's gonna be equals to a half. Okay, so a half times 2 times 2x plus 3 to the negative 1/2. But you know that 2 times a half is going to give you out. All right. So dy by dx is going to be equal to 2x plus 3 raised to the negative 1/2. 2x plus 3 raised to the negative 1/2. Well, I'm going to do this. All right. So now Remember, we never normally leave our index as negative. So we're going to reciprocate. So dy by dx is going to be equals to reciprocating all of that. It's going to be 1 over 2x plus 3 to the positive 1/2. To the positive 1/2. Recall, a to the negative m is equals to 1 over a to the positive m. All right? But this also is the same thing as 1 over the root of 2x plus 3. 2x plus 3. You get that? Understand that?
Yes, sir.
Are there
Yes,
any
sir.
questions?
Yes, sir.
Is there somebody in the class that does not understand what I'm doing? All right. I'm not going to spend a lot of time on this one because it's really not difficult. This one here, what rule do we use for this one?
Power and square roots.
What is the overall rule? The overall rule is which one?
Product rule.
Sir, the quotient.
Is it the quotient? The
Or is
overall?
the product, is it the product rule?
It is a product rule, yes. Product rule. So it's going to be the product rule, and then within the product rule, we have the power rule. Then we have the square root rule, and the power rule is going to come out of it. So yes, the product rule. So I'm going to give you a few minutes to try that one for me. The first thing you need to do is to convert. The first thing you need to do is to convert. Once you have converted, you are good to go. The first thing to do is to convert. I give you 3 minutes. 3 minutes. Start from it, please. Are we finished? Anyone finished?
Yes, sir.
Nice job. We're still working. Anyone still working? Come on, guys, talk to me now, please. Talk to me.
Yes, sir, I'm still working.
Wrapping up, sir.
Okay. Are you seeing my new screen?
Yes, sir.
All right, do me a favor. Somebody read the question for me, please. Y equals is it
Y equals 2x to the 5 square root x squared minus 1.
thank you. So I'm gonna rearrange. Y equals 2x to the 5th times x squared minus 1 raised to the half power. Do you all agree with that?
Yes, sir.
Yes, sir.
All right,
Yes, sir.
good.
Yes,
And then
sir.
right. And then we're not using the rule. So now Right? So using the product rule right there. So I'm going to call this one my first. I'm going to call this one my second. So remember, it's a first. The differentiation of the second. That's the second times the differentiation of the first. First times the differentiation of the second plus the second times the differentiation of the first. All right, so that's what I'm doing here now. So dy by dx is going to be equal to the first, write it back, 2x to the fifth times the differentiation of the second, power rule. So it's going to be a half times x squared minus 1 to the negative a half times the differential of the inside, which is 2x plus the second, which is x squared minus 1 raised to the half power times the differentiation of the first, which is 10x to the fourth. Do you agree with that line?
Yes, sir.
All right. So dy by dx is going to be equals to, wow, 2 times a half is 1, and 1 times 2 is 2. So I'm going to get 2x to the fifth times x is x to the sixth times x squared minus 1 to the negative a half plus 10x to the fourth times x squared minus 1 to the half. Do you agree with that?
Yes, sir.
No. Based on a conversation we had the last time, what is my next step?
You see what two powers are similar or something like that.
Okay, and what do you say are similar?
X squared minus 1.
And is there anything else come? No, but that's incomplete, or
Is
Randy.
the part that 2 is a
Oh.
factor of 10? Or
Very good. So 2 is a fraction. 2 is a factor of 10. What else? Randy, you're incomplete a while ago. Randy said x squared minus 1. But it's not just x squared minus 1. So come back again, Randy.
And a
What
half.
is it?
Half.
Positive.
X
Positive
squared
half.
minus 1.
Okay.
Huh?
X
Half.
squared minus to the positive half power.
Right.
Okay.
Positive times to negative.
You, Randy. What am I doing right here? Which one am I factoring out? Talk to me, somebody. Which one am I factoring out?
So are you factoring out the 2 and the 10, the 2x6 and the 10x4?
When I factor all those, what do I get?
Sir, 5x squared?
5x, yeah.
5x squared. No, what are my factors? Tell me the factors. What are the factors?
So repeat that.
What are the factors? What am I factoring out?
The 2 and the 10.
You said 2 and 10, but I can't take out the 2 of them one time. Give me the factor. What am I supposed to write?
Is it 10x to the 4 divided by 2x to the 6? I don't know.
You guys are not following what I'm talking about. So, what is common here, that is common there, is going to be 2x to the 4th power. 2x to the 4th power. Because 2 is a factor of itself and is of 10, and x to the 4th is what I can take out. Do you agree that this is what I'm going to factor out now?
Sir, how you get 2x to the 4?
And that's why I don't think you guys are fully understanding. All right, let me ask Randy something. Randy, come back here, please.
Yes, sir.
All right, you said x squared minus 1 is common. What do I factor out with the x squared minus 1? What do I factor out? X squared minus 1 what?
Half, positive half, and negative.
Positive half? Is she correct, class?
Yes, sir.
Is there anybody in the class that disagrees with her? Or all of you agree?
Sir, can it be the negative or it has to be the positive? Asking. I'm not
I
sure.
am asking you, Cheyenne.
Sir, Mr. May I go with the negative? The negative I have.
What? Why, Cheyenne?
Sir?
Why?
I don't really know why, but
It's a gut feeling.
yes, sir.
All right. Is there anybody in the class that agrees with Randy or you agree with Cheyenne? And if you agree, you have to tell me why. And if you don't talk to me, I will call upon you. Makeda, you are talking about class start, class start 8:30. And you're coming to class 5 minutes to 9. Answer my question.
Yeah, but my Wi-Fi is kind of going in and out, so that's why I came off and had to come back on.
All right, then I forgive you. Tell me, out of Randy or Cheyenne, who will you agree with?
Sir, I'm not really sure. I know that you would have to factor out the 2x to the 4 because 2 is a factor of 10, and then the 6, you cannot take you'd have to take the 4 out of the 6, which would leave 2, if that make any sense.
It makes a lot of sense. So tell me now, when I look at the x squared minus 1, what am I supposed to factor out?
So the negative, because
Why?
it would be smaller,
Why?
because it would be smaller.
You have to get back on a positive number. They have to factor out the negative. They can become the positive.
Yeah. What, Makeda? Use that
Yes,
word again for me, because it what?
it's smaller.
All right. Cheyenne, Randy, you hear what she says?
Yes, sir.
We're always taking out the smaller of the two because we are factorizing. And when we factorize, we always take out the smaller. That's how we take out the smaller one, because we're factorizing. So therefore, it has to be into the negative half because it is the smaller of the two that we're taking out. Do you agree with me? Do you see where I'm coming from?
Yes, sir.
So It is always the smaller of the two that we take out. So we can't take out x to the 6 because x to the 6 is bigger than x to the 4th. So we have to take out x to the 4th. And of the x squared minus 1 to the negative a half, and the x squared minus 1 to the positive a half, I have to take out the negative 1. Because the negative a half is smaller than the positive a half. So you always take out the smaller of the two. Always remember that, please. Thank you, Makeda. All right, now answer me this question. What is left? What is left?
Five x squared.
What is left?
Five x squared, sir.
Remember now, I have two terms. I have one term here, and I have another term here. I'm asking you the question, what is going to be left? Hold on a minute, please. A student calling.
Sir, is it 5x squared x squared minus 1.5?
Hold on. Randy,
Yes, sir.
you have a number for Mark, really?
Sir, I'm not sure. I'd have to check.
All right, he was just calling me a while ago, so message him for me, please. I don't know if he has the link for the class. Can you send him the link for me, please?
Okay, sir, no problem.
Thank you. All right, sorry, where was I a while ago? I just got distracted. What was I talking about? Yeah, what is left?
Sir, 5? You put 5 right there, sir.
Let me put right here, so what will multiply 2x to the 4th to give me 2x to the 6th?
X squared, sir.
Yes, thank you. So we have x squared left. What else do I have left?
Sir, the x squared minus 1.
But remember now, you know. Remember now. This is x squared minus 1 to the negative a half. And I already have a negative a half here. So is there anything else that I can factor out from here? Anything else left?
The positive a half.
Oh, I follow me something, man. Yo, look at the something now. It said x squared minus 1 to the negative a half. And up here say x squared minus 1 to the negative a half. So is there anything else for me to factor out? Yes or no?
No, sir.
There's nothing. Because when I multiply, watch me. When I multiply 2x to the 4th by x squared, I'm going to get 2x to the 6th. Talk truth.
Yes, sir.
I'm going to multiply. What do I multiply by x squared minus 1 to the negative a half to give me x squared minus 1 to the negative a half?
One.
One.
So there's nothing more for me to multiply by. All right, so let's move on to the other one now. Good. So I'm a plus sign. What do I multiply by? 2x to the 4th to give me 10x to the 4th.
5.
5. Very good. Very good. All right. Listen to me very carefully now. Do not answer me until you have thought about the question. My question is, what do I multiply by x squared minus 1 to the negative a half to give me x squared minus 1 to the positive a half? Answer me now. What?
Sir, this is a stretch, but could it possibly be 1 to the negative half?
Okay, I like the stretch, but no. Think about it again. What do I multiply by x squared minus 1 to the negative a half to give me x squared minus 1 to the positive a half? Malik, answer me. Octavia, come on. Nanika, what is the answer? Talk to teacher.
Sir, is it the same negative a half? I know.
No, it wouldn't be negative a half. Imar, what say you? Bramwell, unmute. Bramwell, unmute the computer, please, and answer the question. Kemar, are you hearing me?
Sir, is it -1?
No, but close-ish. Close-ish.
Sir, me not hear you.
I'm saying that you're very close. You're very close. You're very close. Bramwell, unmute for me, please. Can somebody tell Kemar Bramwell to unmute for me, please? Yeah. Who was this a while ago?
Sir.
Yeah.
Yeah, sir.
Would that Leroy?
Sir.
Sir.
Kemar?
Yes, sir.
What is the answer?
Sir, I would say a -1.
No, you and Cheyenne said the same thing. Close.
Sir, would it be x squared minus 1 to the -1? Or no?
No. Who is iPhone?
Sir, 1 to the -1.
No.
Sir, that?
No, it's not it.
So
Is it 1?
Sorry, say it again.
Sir, I'm asking if it is 1, +1.
Why is there a positive one, Melissa?
Because, sir, when you multiply everything and you multiply negative by a positive, you get back a positive everything.
No, hold on there.
Would it change the
What
figure?
did you say a while ago? Say it one more time. When you multiply negative by what?
A positive, you'll get back a negative. And the 2x minus 1 would remain the same.
All right. Your reason is wrong, but your answer is correct. Your reasoning is wrong, but your answer is correct.
So the answer is 1, sir.
It has to be 1, yeah. 1 minute. Who is iPhone? Somebody's iPhone. Who is that person? The person in the class who is iPhone. Can you identify yourself, please? Or else I'd have to drop you. Can somebody ask the person for iPhone to identify themselves for me, please? This is my final request. Person who is there for iPhone, identify yourself, please, so that I can change your name. Who is that person? Going once? Going twice? And I'm sorry, but you are gone. I'm going to put you in a waiting room.
Sir.
Yeah.
So you did say our answer right, but our reason wrong, right?
Yeah.
So, sir, I was saying that the answer is 1 because when it times 1 times x square, you get back x square. And then when it times 1 times -1, you get back the -1 because any positive number times a negative number, you get back a negative number, right?
Yeah, but not fully what I'm looking for. Let me show you what I'm looking for.
Terminal area.
And I'm saying not fully what I am looking for. Let me show you what I'm looking for. X minus 1 to the negative a half times x squared minus 1 to the positive 1. When I multiply those two, what do I get? When I multiply those two, what do I get?
X squared minus 1 to the positive 1 over 2.
Very good. So I'm going to get x squared minus 1 to the half. Because when I'm multiplying and the bases are the same, I add my powers. So I'm going to get x squared plus x squared minus 1 to the positive half, which is what I want here. So if you look here, so we have x squared right here. If you look right there, and this is exactly the same thing. X squared minus 1 to the positive half. But because I want that, I have to multiply this by a positive 1. So if I had multiplied it by negative 1, I would have gotten x squared minus 1 to the negative 3 over 2. And that would not have been my correct answer. So I had to multiply by the 1 in order for me. Remember, a to the m. A to the m multiplied by a to the n is equal to a to the m plus n. Is equal to a to the m plus n. So what I'm going to have now for the rest of the question, are you following me?
Yes, sir.
So we have x squared minus 1 to the negative half times x squared plus 5x squared minus 5. Am I allowed to do this multiplication like that? Am I allowed, question, am I allowed to do this multiplication? Yes or
Yes,
no?
sir, because the number is in front of the bracket, so you are allowed.
Is that the reason why I'm allowed to do that? I spoke to you about this last class. Is that the reason why I'm allowed to do it?
Sir, because the power is the less than is 1 and less. They are allowed to do that. But if the power is greater than 1, you couldn't do it.
No, but hold on. You said the power is 1 or less. No, not even less. Because I'm not allowed to multiply 10x to the fourth. I can't multiply 10x to the fourth by x squared minus 1 to the half. So I can't do that. So allowed because the power is EXACT is exactly 1. So I'm allowed to do that because the power is 1. If the power was greater than 1 or less than 1, I couldn't do it. The power is exactly 1. That's why I'm allowed to do it. The power is exactly 1. That's why I'm allowed to do it. All right? So now, in finishing off the question, I'm going to say dy by dx is equal to 2x to the fourth times x squared minus 1 to the negative half times 6x squared minus 5. Which is what we answer. In the question, do you agree? Am I correct? Am I missing something? Should I do something else? What I say that's my final answer. Is that really my final answer? No? Are you hearing me?
Sir,
Yeah.
you're not gonna put like instead of writing negative a half, you're not gonna put it over the square root or something like that.
Very good, Cheyenne. Very, very good. And that's why I was waiting. Because I did say to you that we never normally write or answer as a negative index. So it's going to be 2x to the fourth times 6x squared minus 5 all over x squared minus 1 now to the positive half. And that in and of itself can be written as 2x to the fourth, 6x squared minus 5 over, watch this, don't blink, watch this, the square root of x squared minus 1. And no, that is my final answer. Do you agree? Do you see what I have right there?
Yes, sir.
So, sir, basically
Right.
only the top number change, but not the denominator.
Say it again.
Only the top number change, but not the denominator.
Which denominator? I don't have a denominator there.
The square root, sir, and the x.
No, man. What is in the parentheses don't change. It's just a power that change. You follow me, Lisa?
Yes, sir.
No, all right. So if you look at the screen, I had done the question for you. I type up the question. Just look to see what it is that I have done there. Just look to see what I have done right there. So it says I'm using the product rule, the first and the second, and it's going to be the first. It's going to be the first. See it right here? Times the differentiation of the second. And then differentiate the second, this is going to become a half. See it right here? X minus 1 to the negative a half, because I'm subtracting 1 from the power. See it here? Negative a half times the differential of the inside. And then differentiate the x squared, I'm going to get 2x. See it right here? So plus the second, x squared minus 1 to the half. See it here? Plus the second times the differentiation of the first. And then differentiate the first, I'm going to get 10x to the fourth. See it right here? So my differentiation ends with what is in blue. What is left is going to be my fixing up my algebra. So I'm going to look now, I'm going to do some multiplication. 2x to the fifth times a half is 1x. This is 1x to the fifth. And 1x to the fifth times 2 is going to be 2x to the sixth. See it right here? And my x squared minus 1 to the negative a half is right there. And 10x to the fourth is right here. X squared minus 1 to the positive a half is here. And recall, always factor out the smaller of the two. You cannot go wrong if you follow that rule. You can't go wrong if you follow that golden rule. Factorization means that you are factoring out the smaller of the two. No other way. All right? And then I'm going to see what is common. Now, what is common is going to be your 2x. 2 is common here, and 2 is common to 10. Of x to the 6 and x to the 4th, which is common, the smaller of the two, which is x to the 4th. So that's why I'm factoring out the x to the 4th. Of the x squared minus 1 to the negative a half, or the x squared minus 1 to the positive a half, which is smaller? Yes, the x squared minus 1 to the negative a half, so I'm factoring it out. Right here. Then I ask myself the question, is there anything else that is common? And the answer is no. There's nothing else common. So because of that, now I'm going to close my parentheses and I'm going to look at the question. What do I multiply by? What do I multiply by? 2x to the fourth they give me 2x to the 6. X squared. I don't have to worry about x squared minus 1 to the negative half because it is exactly x squared minus 1 to the negative half right here. So I don't have to worry about that. Then I ask myself the question, what do I multiply by 2x to the 4th to give me 10x to the 4th? Answer is 5. Answer is 5. And then now, I'll ask myself the question, what do I multiply by x squared minus 1 to the negative half to give me x squared minus 1 to the positive half? It has to be x squared minus 1 to the positive 1. Because when I multiply and the bases are the same, I add my powers. Negative a half plus 1 is going to be equals to positive a half. And because this one here is up top, it is our positive 1, I am able to distribute this 5 over x squared minus 1. And then I'm going to have 5 times x squared is 5x squared. And 5 times negative 1 is negative 5. And I'm grouping like terms. 5x squared plus x squared is 6x squared minus 5. And then what I'm going to do is, because this here is to the negative a half, I'm going to divide it by, put it in the denominator to give me a positive a half. Getting my positive a half there, I can convert it to the root of x squared minus 1. Are you with me right there? Hello? Are you there?
Yes, sir.
Are you understanding? Somebody talk to me.
Sir, 75 there, sir. But just
What
we going to recheck, sir, and come back.
is, okay, Malik. Um, is there anybody else with a comment? Are you understanding what I'm doing? Are you having any challenges? What are your questions? What are your thoughts?
Your question, sir, where you get the 2x over 6?
2x over 6?
No, 2x and then the 6, sir. Where do you get that? Just that alone I have problem with, because I get the other parts.
Oh, I get this 6.
No, sir, sir.
Really, sir?
Yes, sir, the one inside.
Inside what? This one right here?
Yes, sir.
1x squared plus 5x squared give me 6x squared. Lisa, you seeing it now?
Yes, sir.
Are there any other questions? Are you okay? Are you with me? Any other questions? Malik, you're supposed to come back to me on something. What what are you seeing right there, Malik? I thought you were checking on something. Guys, talk to me, please. Talk to me.
So it was the 6x squared I was talking about, sir, but I see how I get it, sir.
Okay, all right, then cool. All right. Is there anybody else that is having a challenge, or because I'm done with that now, you know, that is finished. I mean, I don't have anything else to show you right there, other than to move into another topic. There are other questions that we'll get, but I'm not concerned with doing any other questions as it is just no. It's just for you to recognize the whole business of when you're getting to factorizations, you always factor out the smaller of the two. It's very important that you recognize that we're factoring out the smaller of the two. All right. Are you okay, guys? Are you understanding what it is that I'm doing? I have 20 minutes and I want to move into something else, but I just need to find out from you. Are you understanding? Are you okay? Talk to me. Abby, what do you mean by kind of? Talk to me. It's an opportunity to get something else. What is it that you're not seeing, Miller?
Alright, so with this question here we have like 2x to the fourth, and you have x to the call this x to the 2 minus 1 negative a half. When you have the different brackets, we kind of get a bit confused.
Okay. All right. What I'm going to ask you to do, is see how best you can go through what it is that I have done. Just take your time and go through it because it only gets better with practice. It only gets better with practice. It only gets better with practice. So you have to practice this stuff in order for it to happen. It only gets better with practice. All right. No, I'm going to move into something else, but I just came onto my Edico to look at something, and I'm seeing there are students in the class who are here now in class physically that have not yet logged on to their EducaSoft to do any work.
Sir,
Yeah.
Jay, you're going to send us this working out sheet?
I normally do.
Okay.
But why is it that there are students in the class no that are not completing my work on Edico? Alyssa, are you in class now? Alyssa Campbell?
Yes, sir. Yes, sir.
Pick up yourself here. Pick up yourself.
Yes, sir.
Because you are working on your Edico and you are doing very well. Right? You have gone 6 assessments so far. Very nice. Continue working hard, all right?
Yes, sir. Thank you.
No problem. Is Tanisha here? Hilton. Tanisha? Hilton, are you there? Well, Hilton is not there, but Hilton has been doing exceptionally well. Hilton has completed 12 pieces of work on Edicasov. She's almost done. With excellent grades, as a matter of fact. With excellent grades. The others of you have started, but I'm seeing, well, Mark Raby is at 6 as well. And Jauna has completed 7 pieces, right? There are others who did 5, but I'm not calling the 5. I want you to complete more than that. So Jauna is at 7, Mark Raby is at 6, Alisa is at 6, Tanisha is at 12, and that's about it. Some of you don't start yet. Some of you don't start yet. Danica Plummer is at 5, completed assessments. Malik Mackenzie is at 5, completed assessments. Rian is at 4.5. And that's about it. The rest of you are 0 to 4. So come on. I need to see you guys completing the work on Edico. You can't want to pass the course and not doing the extra work. I can't support that. I can't support that, please. By Thursday's class, I want to see I want to see more movements. I want to see more movements. All right. All right, I'm just checking on something with the syllabus. Okay, so I am finished with Unit 4. Unit 4 was differentiation from first principles. I did that with you. I am on to differentiation by rule, single variable. Differentiate. All right. Are you seeing the screen? The syllabus on the screen?
Yes, sir.
All right, because what I want you to do, I'm sorry. What I want you all to do is to hold me accountable. Just as though I'm holding you accountable. I would have done limits with you already. I would have gone through continuity. The 3 rules for continuity. Average rate of change is so easy. Average rate of change is average rate of change, f of b minus f of a over b minus a. As I did with you, I did a 1 question with you because there's nothing more to it than that. I did differentiation from first principles. I am now on differentiation by rules, looking at single variables. All right. So it says use rules to differentiate single variable algebraic functions, exponential functions, sorry, and logarithmic functions. Differentiate single variables, algebraic functions, exponential functions, and logarithmic by substitution, and perform differentiation to obtain higher derivative for the second and the third order. Talk about a constant of addition, product, quotient, chain, and those different rules. And then now, on Thursday, God's willing, hopefully my voice comes back and I can come into physical class. I am going to be moving into what we call applications to differentiation. We're going to talk about applications to differentiation, talking about our stationary points and our marginal cost, profit. And then I'm going to move into integration. And hopefully I can finish the syllabus on time so we can have enough time left over for revision. All right. So just to point out, I just needed to look at the syllabus to make sure that what it is that I'm doing is where we're supposed to be. And exponential functions and logarithmic functions. Yes, so I am where we're supposed to be. All right. So I'm going to stop sharing this one here. And let me give you a question to do for me. Let me give you a question to do because I want to see how well you're able to transfer the knowledge. I'm trying to find a past paper question. And we're going to do this in 5 minutes. All right. All right. Let me see if I can share the screen here. All right, December 2013. The question says to differentiate y equal ln 7x plus 6 e to the 5x minus 4 with respect to x. With respect to x. All right. Question. Anybody remember the ln rule that I use with them? Anybody remember the ln rule? Talk to me, please. Students, talk to me, please. Are you hearing me? Oh, come on, guys. You're making this hard. Talk to me now, please. You're making this hard for me, man.
Sir, is it the differentiation of the exponential function, right?
Yeah, man.
It is.
No, hold on. What I was asking you is, do you remember the ln function that I show you how to differentiate the ln function?
Sir, I wasn't here when you did that.
Who is that, Lisa?
Yes, sir.
Right, I know you weren't here in the last class, but anybody remembers the ln function?
Yes, sir.
Okay, good. So let us work through this question together. It says to differentiate y equals ln 7x minus 6 times e to the 5x minus 4. What general rule do we use for this one?
The differential of the exponential function is the exponential function itself.
Good, but what rule do I use for it? Do I use a chain rule, a product rule, a quotient rule? What rule is this?
The chain rule.
No, say the product rule.
The product rule, yes.
Right, it's a product rule, right? So watch me, watch me. Watch me. It is going to be dy by dx. It's going to be equals to, I'm going to call it my first and my second. So this is going to be my first, and this here is going to be my second. So it's going to be dy by dx, my first, the first, times the differentiation of the second. When I differentiate the sorry, when I differentiate the exponential function, I get the exponential function itself. So I'm going to get e to the 5x minus 4 times the differential of the exponential function. The function itself. What is a function? What is the differential of the function? When I differentiate the power, what do I get?
5.
5. So it's going to be times 5. plus the second, which is plus e to the 5x minus 4 times the differential of the first. When I differentiate the logarithmic function, what do I get? When I differentiate the ln function, what do I get?
Seven.
Not 7. Remember, when we differentiate the logarithm, the differential of ln x is 1 over x. So it's going to become 1 over 7x plus 6. And then I'm going to times it by the differential of the function, which is going to be the 7. So that's your answer now, right? So 7 is right there. So recall, y is equals to ln x. Therefore, dy by dx is going to be equals to 1 over x times the differential of this 1. I'm going to get 1, which is equals to 1 over x. So always remember, the differential of the ln function is going to be 1 over the function itself times the differential of the function, the function. The differential of the ln function is going to be 1 over the function itself times the differential of the function. So that's why ln 7x plus 6 is going to be 1 over the function, 1 over 7x plus 6 times the differential of the 7x plus 6, which is 7. And that's how I get the 7 right there. And then we're going to have dy by dx is going to be equals to ln, no, I'm going to call this 5 ln 7x plus 6 times e to the 5x minus 4 plus 7 over 7x plus 6 times e to the 5x minus 4. Everybody seen that one so far?
Yes, sir.
And then I'm going to have dy by dx. I'm factoring out what is common. The only thing that is common there is going to be e to the 5x minus 4. What is going to be left is going to be 5 ln 7x plus 6 plus 7 over 7x plus 6. And truth be told, I'll leave that as my answer right there. Final answer. All right, that's the end of the class. But I need to talk to you about something, my observation. My observation is, I mean, you guys are a good set of students. I really don't know what number I have in the class in terms of how many students I have. There are some students who are not seen in class now. My general observation is that you are not doing enough work on your own. You're not doing enough work on your own. I clearly am not well, and I could have said to you, no class. But because I know it is going to come back to bite me sometime later on, when I don't finish the syllabus, I try to push through. As we speak, my throat is killing me. But it is a price that I'm going to pay because I know that I have to complete the stuff. I am making an effort, not feeling well, coming out to teach. But you guys are not putting in the work. How many don't put in the work? You know, it not gonna make no sense. Very few of you have started Edicosoft. As I said before, I don't want to name and shame people yet, but there are students in the class right now who I'm seeing on Edico that have not even logged in one time. I am teaching, and there are areas that I've already covered, and I'm asking questions and students not able to answer me. It's not good. Really, really, really not good. So this is what I want you to do for me now. Going forward, I'm going to ask that you start doing some work. Start doing some work. Students, the only way you are going to reap success is based on the amount of work that you put in. Now, clear how the teacher good is the amount of work that you put in that you're going to get out. And based on my interaction today, I don't think you guys are putting in enough work because the responses are not coming as fast as I want them to come. And some of them don't even unmute during the course of this class. I'm not even unmuted once to contribute to the class. But please, students, I'm going to ask that you study. Your mid-semester is already prepared. You're supposed to be studying for the mid-semester. It can happen anytime. Thanks for coming out. Thanks for facilitating me. Hopefully, I'll be better where I can come into the face-to-face. If I'm not feeling any better, I don't think I'm going to come out to the face-to-face on Thursday. Let me ask you from now. Do you have a class after my class on Thursday?
No, sir. Last class on Thursday.
So my class is the last.
Honestly, we don't know, sir, because we don't see the new timetable, so we can't give you a definitive answer, sir. Because them change the timetable.
All right.
Remember say school finish at 3 on Thursdays.
Yeah, that's true. That's true, man. School is at 3 on Thursdays for clubs and societies. That question though, which class do you have before my class on a Thursday?
Before?
Yeah.
Caribbean Studies.
And what time is that class?
(9 to 10:30).
So it's only 2 classes you have on Thursday?
Yes, sir.
All right. It sounds great. I'm going to tell you why I'm asking. I'm really hoping that I can feel better because really and truly, this feeling is not a nice one. It really don't sound sexy. And it's not a nice one. And it's very painful. But as I said before, if I'm not feeling well, I'm not going to push to come out on Thursday. I'll rather have the class online. So we're going to keep in touch. There's no school tomorrow because it's a public holiday. I think it's Ash Wednesday. Tomorrow's Ash Wednesday, don't?
Yes, sir.
All right. So if I don't feel better, what I'm going to suggest is, if you don't hear from me by the end of your Caribbean Studies class, what time is it? What time it ends again? 11 o'clock, you say? What time it ends?
10:30.
It ends at 10:30. If you don't hear from me by 11 o'clock, I will ask that you touch base with me, please, right? So that I can tell you exactly what to do. So what I don't want to happen is that you guys sit at school for the online class when it is that you could get home. So I'm going to see if I can touch base with you before, so that immediately following your Caribbean Studies class, you could just head home, straight home, so that you could be comfortable at home for us to have the online class. And for those of you who just have my math class, you could just stay put. Does that sound okay?
Yes, sir.
Am I putting anybody out of your way?
Sir, are you going to send this video, sir?
Yes, man, as I always do. I said the last one, I'm going to send this one, man. And I'm going to send the notes too. But talk to me. Is that okay? Am I allowed to do that on Thursday if I'm not feeling better?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right, thank you. All right, get ready now so you can head out for your Caribbean Studies class. All the best here. Take care.